All right, so we're going to build on our three forms, on our general form, vertex form, and factored form of our quadratics. So we got to be able to like go from between all of them and be able to graph them and do all kinds of things. So this says write the equation of a parabola that has vertex 2, -1 and passes through the y-axis at 3. So if it just says write an equation, we can use any form. Okay? And since I'm given the vertex, I probably want to write it in vertex form. And so we should know that it's y equals, remember it's x minus h squared, so x minus, well, what is the x for my vertex? 2. So x minus 2 squared, and then we have a -1 on the outside, because that's where our vertex is. Remember we use like h and k, and it's at y equals x minus h squared plus k. Well, you got to be careful though. Okay, so this says it has a vertex of 2, -1. So this is right down here, and it goes through the y-axis at 3. So just like that. So it looks something along those lines. Kind of a general graph there of it. Well, sometimes parabolas have a vertical stretch, or a scale is what they say. And so we have to consider that fact every single time. So we've done this on our assignment, but we just have to get used to it that we always have to consider this A out in front, or like that vertical stretch, if you think back to our transformations of our graphs. So what I want to do is I need to solve for this A. Sometimes the A might be 1, and then I wouldn't even need it there. But other times I might have a stretch. Okay, and then in this case, to do that, to solve for that A, I need to plug in a point for the x and the y so I can solve for A. Well, it's important that you don't use the vertex. You can't use the vertex because this is vertex form. So don't use the form that you're using. Do I know any other points that are on my graph? Yeah, it gave us one right here. The y-intercept, so that's at 0, 3. So I'm going to plug in 0, 3 into my equation. So 3 for y. I'm trying to solve for this a, 0 for the x. And there we go. So I got 3 equals a times, well, this is really -2 squared, right? And -2 squared is 4 minus 1. Add the 1 over. So I'd have 4 equals 4a. Then divide by 4, so a is 1. So in this case, I didn't even really need the a because I know my a is 1, and 1 times anything is just what that is. So this still worked out, just like that. Let's try one right here. Let's try one where it gives us the roots. All right, so let's graph this first. So it's got a root at -1 and a root at -3, and it goes through -4, -3. So -4, -3, which is somewhere around here. All right, so it looks like our graph is going to come up like this and drop back down like that. Yeah, pretty ugly, but did the best I could. Might get a little bit higher. We'll find out. All right, so let's start with this. Well, it gave us roots, so what form should we use? Yeah, we want to use our factored form because that's where we put our roots in, factored form. So our factored form is, it's basically you take the x and you subtract whatever the root is. So root 1, and we might have another root, so root 2, I guess you could say. So what we do is we take x, well, minus -1 would really be +1, and x minus -3 would really be +3, just like that. And we still have to consider the fact that there could be a vertical stretch. So I need to put in a here. All right, so let's solve for that a. So what am I going to do? Can I plug in either of these roots into my equation right here? No, because that's what our factored form is. It's using the roots. So don't use the roots. You cannot use the roots. So what I need to do is use another point on my graph. So in this case, I'm going to use this point right here. So don't use the roots. I'm going to use a different point. And the only one I know is the point -4, -3. So I'm going to plug in -3 for y, and then -4 for x. And we would have a times -3 times -1. So that's 3. So -3 equals 3a. So a ends up being -1. And that kind of makes sense because my graph, if you look, is flipped, right? So it's going to be y equals, I could put -1 or I could just put a negative sign, it doesn't matter, and x plus 1 and x plus 3 for my roots. And there we go. And if I wanted in general form, I could just run through my FOIL there and get that expanded out. All right, what about if it doesn't give us a vertex or any root? All it gives us is 3 points. What am I going to do here? Well, you know that it's a parabola. So what degree is that? That's a second degree, right? So it's a quadratic. So think about your standard form for a parabola or a quadratic. That's your y equals ax squared plus bx plus c. So we need to write an equation for this. So I need to know what the a is, the b is, and the c is. So we should be getting used to this. You're solving for 3 variables. How many equations do you need? 3 equations. So plug in a point into your equation. Then what do you get? 0 for y, 1 for x. So 1 squared, 1, and then c. So you had a times 1 plus b times 1 plus c. There's an equation, and then so on and so forth. So keep going. So plug in the next point into there. 42 for y and 4 for x. So 4 squared is 16 and 4 for x. So I'd have 16a plus 4b plus c. And then one more, we got -2, -6. So my last equation, -6 for y and then -2 for x. So I'd have 4a and -2b. So 4a, -2b plus c. And then how do I solve these? Yeah, this is where we go to our system, right? So we type this into our calculator. I got a 3 by 3 with my coefficients. So I got 1, 1, 1 for my blue equation. I got 16, 4, 1 for my green equation, and 4, -2, 1 for my black equation. And remember, we take the inverse of this times the answers, the sums over there. So I got 0, 42, and -6. And this ends up equaling 2, 4, and -6. So there's my equation for this guy. So it would be y equals 2 for the a, so 2a squared, 4 for the b, so 4b, and -6 for the c. And there we go. And if I wanted in factored form, I could factor it. If I wanted in vertex form, well, we haven't quite talked about that yet, so we'll get into that. Well, here we go. Let's write all 3 forms of the parabola. This would be some good practice. So right now, this would be which form? This is my vertex form. So I got one of them down, right? Because the vertex would be at 3, 1 in this case. All right, so if I expand it out, it'll put me in general form. So that's what I'm going to do. I'm going to say y equals, well, how do I expand this out? That's the factored form of a perfect square trinomial. So if you're not sure on that, you're going to have to write it out on the side and actually go through your FOIL. Otherwise, if you do know it, I still have this negative sign out front, so don't forget about that. I'm going to leave that out there. If I do know my perfect square trinomials, I would get x squared, and then it's these two multiplied and doubled. So x times -3 is -3x, and double it to -6x, and then -3 squared, which is +9. And then we have our +1. And then I need to distribute my minus sign here. So that's going to give it to all these, so it just switches all the signs. So really we'd have -x squared plus 6x minus 9 plus 1, which -9 plus 1 is really -8. There we go. So that is general form, or standard form, I guess you could say as well. Your textbook uses general form. And then lastly, we need factored form. Factored form. Okay, well, I got a quadratic. Technically, there's a coefficient of -1 here. So I'm going to factor out that negative, okay, because having that negative there makes it a little bit more difficult to factor. So I'm going to pull that -1 out. And I got x squared plus 6. Oh, then now it's going to be minus, right, because I'm dividing everything by a negative. So -6x plus 8. All right, I'm pulling that negative sign out of each of those terms, a -1 really. And now that would break into a product of 2 binomials because I'm finding factors of 8 that add up to -6, which happen to be -4 and -2. So I'd have x minus 4 and x minus 2. So there's our factored form. Good, so there's all 3 forms. Let's try another one here. So which form is this? This looks like it is a factored form. And what do we know about factored form? What things are given? Well, the roots are given, correct? The roots are the zeros. So what would the roots in this case be? They'd be at 5, 0, and 1, 0. Remember, it's like whatever makes this equation 0. So 5 would make it 0, and 1 would make it 0. So those are the two roots. All right, so for general form, we just expand it out. So it doesn't matter where you start. I'm going to do my FOIL first. So I'm going to go x squared. And then I got a negative 1x. And then a negative 5x, which combined to a negative 6x. And then negative 5 times negative 1 is positive 5. And then I still have to distribute my negative 2. So I'd have y equals negative 2x, positive 12x, and minus 10. So there is my general form. And how would I get my vertex form? Well, for the vertex, okay, one thing that you should have noticed from your assignment, and if I look back, at a couple of my graphs here, I should probably fix this graph, make it look a little nicer, is if I compare the vertex to the roots, the vertex here is at 2, negative 1. And my roots are at 3, 0, and 1, 0. So what do I notice about the vertex compared to the roots? Yeah, it's right in between. It's like the midpoint of the roots. It's like the average of the roots. So the x on your vertex is the average of the roots. All right, so let's go back to this other one. So if my roots are at 5 and 1, what would my x and my vertex be? Well, it'd be the average of these two. So 5 plus 1 divided by 2, so 6 divided by 2, which is 3. So I know it's 3, but how am I going to find the y? Well, how would I find the y? Well, the easiest way is to just plug in that 3 into your equation. Doesn't matter which one you use. You could use your general form. You could plug in the 3 here, or you could use your factored form and plug in the 3 up here. I like the factored form. That seems like it's going to go. Either one seems like it's going to be equal amount of time. So if I do the general form, I'd get negative 6 plus 36 minus 10. So we'd have 30 minus 10, which is 20. So the vertex is at 320. So when I write my vertex form, I know I got x minus 3 squared plus 20. And I should always consider the fact for this a. So I need to solve for this a. I should plug in a point to solve for a. Or I should be noticing that, take a look at all my forms. What was in front on all these? The vertex had a negative. The general had a negative. The factored had a negative 1 out front. They all had a negative 1. What about my other one here? So that all three forms share the same scale in front. So if this one has a vertical stretch of negative 2, the general form will also show this stretch of negative 2, which means my vertex form should also have a negative 2. So I don't even need to go through the work to solve for that. I already know that the vertical stretch is negative 2, and there would be my vertex form. Okay, so it takes a little bit of work. So remember the vertex, to find the x, it's like the average of the two roots. The average of the two roots. That'll help you. So some things with this guy, I would start by finding roots. So if you're given general, find factored form. Go to factored form next. Don't go to vertex form. We could go to vertex, but that's coming up in the future. So what I would do here is I would have to factor out a 3 right away. X squared minus 6x minus 7. And then I would find factors of negative 7 that add up to negative 6, which happen to be negative 7 and 1. Kind of go through this one quick. So there's my factored form. And then remember, for the vertex, it's the average of your roots. So what are your roots here? Your roots would be 7 and negative 1, right? Because you're looking at what makes these 0. And what's the average of these two? We'd have 7 plus negative 1, which is 6, divided by 2, which is 3. So for my vertex, I know that the x is 3. And to find the y, I would have to plug that in. So I'd plug that 3 in up here and up here. So I would have 9. So this is 27. And here would be a 3. So this would be 18 times 3, which is 54, minus 21. So we get negative 7 minus 21, which is negative 48. Hopefully I did that right. I went through that pretty quick. So vertex form, y equals x minus 3 squared minus 48. And for the vertical stretch out front, it should just match. So we got a 3, we got a 3. This should also be a 3. So there's all 3 forms. So the things we notice, they all have the same vertical stretch, the same leading coefficient, right? And we already just talked. It gives it its vertical stretch. So that leading coefficient does the vertical stretch to it. The x-coordinate of the vertex is always halfway between the roots, right? We just talked about that. It's like the average of the 2 roots. And then how do you find the y? You just plug it in. Plug in the x into any of those equations you already have came up with. And the roots of the parabola, remember, are when y is equal to 0. That's why they're also called. So lots of things with quadratics. Lots and lots of things. We should be able to write in all 3 forms, though. That's kind of the most important thing we should take from this.